Hey, what up, guys? This is Ryan with Brainstorms. And solving equations with variables on both sides of the equal signs means just that. So here's the equal sign. And now instead of normally we kind of have like x or 5x or 10x on the left side and some numbers on the right, now we have x's on both sides of the equal sign. So that's kind of weird. That looks unsolvable, right? And the way to fix that, or the way to solve these equations, is to simply just not be okay with that. I'm not going to live my life like this. I can't have variables on both sides. So the first thing we do is fix that. We're going to move all the variables to one side. The rule you kind of have to know before we even start, it doesn't matter which side. You just want all of your x's on the one side and all of your non-x's on the other. I typically move everyone to the left, but it depends. Sometimes you can move your x's over to the right, whatever. And so how do I move a variable across the equal sign? Remember, it's just algebra. You do the opposite of whatever it is. So it looks like this is, I'm kind of targeting this x. How do I get this x over here? Remember, you always do the opposite. This is a positive x, so I'm going to minus x to both sides, right? And now you'll notice, here's my equals. It stays right here. Well, x minus x, it just cancels itself, which is the whole point. And then the 8 is still there, so he just carries down. And now on this side, I have 3x minus x. That would just be 2x. And now we don't have an equation with variables on both sides of the equal sign. Now we have our x's on the left and our non-x's on the right. Perfect. Now we can solve. Okay, well now I have 2 times x. What's the opposite of times? Divide both sides by 2. He's gone. X equals 4. Cool? So the first step is to just not be okay with having variables on both sides. Move them to one side. And most of the time, I'll probably be moving them to the left, but I'm sure some examples will come up where we'll want to move them to the right. So let's check them out. All right, so here's a bunch of examples. And I guess before we jump into too many random examples, I kind of feel obligated to prove that what I said is true. And so here's the same equation, 4x equals 2x plus 6. 4x equals 2x plus 6. In this one, I'm going to put all the variables on the left, all the x's on the left, see what I get. In this one, I'm going to move my x's to the right and see what I get. Okay, there's like a fun little experiment. So, okay, if I want to move him over here, what's the opposite of positive 2x? I'm going to minus 2x to both sides, right? That cancels, which is the whole point. The 6 is still alive, so he's there. 4x minus 2x is 2x. Divide both sides by 2. Sure enough, x equals 3. Okay, let's see what happens here. I'm going to move this 4x over here. I'm going to minus 4x minus 4x. Watch what I get. This is kind of weird. The equal sign is there. 4x minus 4x is gone, but what does that mean to be gone? There's a 0 now, right? So this is 0. And then over here I have 2x minus 4x is negative 2x plus 6. Well, that's not cool. I'm going to minus 6 over here, right, to get him out of there. Now I have negative 6 equals, that's gone, negative 2x. Divide both sides by negative 2, negative 2, he's gone. X equals negative divided by negative is a positive, so that's 3. Yes, this one over here was terrible, right? And that's the whole point, is that sure, you can do it both ways, but one way is kind of easier, right? And so the one where you keep your variables positive is usually easier. All right, so now let's do a bunch of examples. Since I've proven that I wasn't lying, you can put everyone on the left, or you can put all your variables on the right, and it'll work either way. All right, check it out. Okay, so here's 2. So this one on the left here, well, obviously this 2x is pesky. Let's get him over where he belongs on the left. So what's the opposite of positive 2x? No problem, minus 2x, minus 2x. And I'm doing it to both sides of the equal sign. Some people visualize like an actual brick wall, right? I'm putting it over the brick wall to the other side. Okay, so this is 7x equals, that's gone. 14 carries down, right? And then divide by 7 is my final step. That one came out pretty clean. X is 2. Okay, what about this one? Same thing, right? I have an x over here and x over here. So how do I get this guy over here? It's the same rule, but now it's kind of funky because it's a minus x. Who cares? What's the opposite of minus x? Plus x now to both sides, right? 5x plus x is 6x equals, he's gone, which is the point. 12, divide both sides by 6. X is totally 2. Easy. All right, here's a couple more. All right, and this one, the numbers may be weird, but are a little bigger, but it's totally easy. Minus 6x to both sides, right? And it looks like I get 4x over here equals, that's gone, 40. No big deal, divide by 4, x equals 10, cool. All right, so this is the one that is tricky, right? And so, I'm like, well, I could move my 7x over here. Right away, I kind of see if I minus 7x, wouldn't I get 2, I get a negative, and then I have to move the 10. This is like kind of backwards, and so what do? You definitely want to move your 2x to this side, but let me make a point here. if you have something like 5 equals 3 plus 2, which is true, 5 equals 3 plus 2, couldn't you just write 3 plus 2 also equals 5? Couldn't you flip the whole equation? So any equation can be flipped. You could also write this as 7x equals 2x plus 10. No problem. That is absolutely true. I just took this piece and this piece, flipped them because they definitely equal each other. But I don't really want to give you that hint, so I'm going to pretend like I didn't teach you that, and we're going to solve this one backwards. Right, now that you don't know that you can write them backwards, well, let's see what we can do. I think this time we should move the 2x to the other side, right? Minus 2x, he's gone. 10 equals 7x minus 2x is 5x. Divide both sides by 5, and now you get 2 equals x, which is the same as saying x equals 2. Who cares? It's the same thing. So there's one where we moved everyone to the right, all of our variables to the right. But again, we could have outwitted this system anyways. All right, so here's a couple more, and then we're totally done with these. Okay, so the last two, just to be mean, I made this one the same, where it's like, wait a minute, I think I should move him over here, and the non-x's can stay on the left, right? Okay, so minus 3x. Minus 3x, okay, he's gone. Negative 12 equals 3x, 6x minus 3x. Divide by 3, negative 4 equals x. That is my answer. Again, if you're cool, and because you know me and I showed you this, you could be like, I don't like this. I'm just going to write it backwards, and now it kind of looks a little more like what you're used to. That is totally fine. Don't tell anyone I told you that. All right, so now look at this one. I don't know, it looks like this is pretty mellow. I could just add my 2x to this side and this side, right? Now I have 14x equals, he's gone, 28, divide both. I don't know why every single problem came out to 2. That was like an accident. My bad. I didn't mean for every single one to come out to 2. But now you get it. So solving equations with variables on both sides of the equal sign, first thing you do is don't be cool with that. Move the variables so you don't have variables on both sides, and then you have a normal algebra problem, and then you can totally bust it out. All right, you guys, good luck.